Hello guys, this section consists of generics. Generics is a new feature in Java 5. Besides the other multiple functions that generics can be useful for, one of them is type safety. Let's look at this pre-Java 5 code that creates a list. It takes string values, and then we iterate the list and concat a dot. So far we didn't have issues, but if we add a boolean type value, for example, we get a class cast exception which failed when casting to a string a boolean type, and both are incompatible types. With generics feature, we make safe declarations by placing the generic type. Notice the compiler error when we attempt to add a boolean type in a generic string list. Notice how the compiler gives us warnings when we do not use the generics implementation. Because in legacy code you might find non-generic implementations, as stated in the objectives, you are expected to recognize legal implementations when generic and non-generic code mix. Let's get back to the priority queue implementation we checked in the previous video. In this class, I will create a method that will take a queue object and adds integer values to it. Now I will create a linked list implementation. Here I add some string objects, and then put the linked list object in the method. If you studied this section well, what do you think will happen here? Well, nothing has happened. Another element added to the list. Notice though how we could pass a safe generic collection into a non-safe collection. From the non-safe part, the generic quits all responsibility for further usage of this collection. Now let's check this one. We will do the same with the priority queue object. Both belong to the queuing interface, and the linked list part work. Why shouldn't it work, right? And there we go. We got a class cast exception. But why? Before answering, my expectation for you is that you understand to the bone each collection implementation from the previous video section. The implementations from list, set, and map interfaces. I can't emphasize this enough. The source code of this project is available so that you can tweak it, build so many other implementations, and excel with the generics, collections, and the exam in general for the other sections. Back to the priority queue, all I will say, this collection must have objects of the same type, mutually comparable to each other. That's why we failed to add the integer value. As from the objectives themselves, this is some of the generic and non-generic mix scenario you will see in the exam. For the case of polymorphism, let's check at this collection which has a list of type object. We can put a list as reference variable and assign an array list new instance. As far as we know, that is how polymorphism structure works. If we apply the same with the generic type, we get a compiler error. When working with generics, the generic reference must be of the same type as the assignment, exactly the same, or you will have a compiler error. This doesn't apply to string though, where polymorphism works. We will create two methods. One of them will be a method that takes a shape array and iterates it. The other will be a method that takes a shape list and iterates it. Our first aim is to pass a shapes, circle, and triangle array to the getShape method. If we run this, the program gets executed fine. Therefore, we don't have issues passing arrays into a parent object as argument in a method. Now let's do the same with the lists. We will create a shapes list and a circle list and pass them to a getShapesList method. If you can see, we got a compiler error that says that list shape is not applicable for list circle, meaning that even if circle is a subtype of shape, we can't put anything that's not from the type declared in the method's argument. So polymorphism works with arrays, but it didn't work for lists. And there are design reasons for this. Imagine if we could put a subtype list circle, and inside this method we add a triangle. We could be putting a triangle object in a circle list, and this could not be a very good design. Notice though how we could put subtypes into the shapes array. And how we can put subtypes into the shape list, we don't have issues about that.